Hey everybody, it's Mrs. Fisher. We're doing today Unit 7, Day 6, Graphing Polar Equations. Now, to graph polar equations, we're basically going to combine what we've done over the last 2 days, and that is plotting points in polar form and working with equations in polar form. Now, with rectangular form, we would be accustomed to seeing equations like y equals, like 2x plus 5, something like that, where you have y by itself. In polar form, you need to have r by itself to plot points and then graph. So just like when you first learned how to graph regular equations, we are going to graph by making a table. Now our table is going to have r's and thetas because those are the points that we plot. All right, and in this situation, theta is our independent variable and r is our dependent variable. So we are going to choose numbers for theta, substitute them into the equation, and find out what r will equal. So our theta values are going to be the ones that we see on our graph paper. So we're going to use 0, 30, 45, 60, 90, 120, 135, 150, and then 180. And then from there, we are going to do the bottom half of the circle. I'm just going to make a new table. And work our way around the bottom. So 210, 225, 240, 270, 300, 315, 330, and then back to the beginning, 360. Now for most of these equations, if you just go around one full circle, you will have enough points to get your entire graph. Sometimes you have to go around more than once. Sometimes you only have to go around half of a circle, but I would say 90% of the time, you can just go one full circle and have enough for your full graph. Now you are going to substitute these numbers into your equation and then solve for r. So for the first one, we are going to substitute in 0. So we're going to have 3 plus 2 sine 0. And then 3 plus 2 sine 30. And so on. Now the nice thing, if you remember all of our work with these circles, and especially the unit circle, all of the angles in quadrant 1 and in quadrant 2 have the same sine value. So as soon as we find our answers for quadrant 1, our values are going to repeat for the angles that are in quadrant 2. And so even though it looks like we have a lot of work to do here, it's really not that bad because of the repeating values. Okay, so starting with 3 plus 2 sine 0, you want to ask yourself, what is the sine of 0? All right, sine of 0 is 0, multiplied by 2, keeps the 0, and then plus 3, we get an r value of 3. 2 sine of 30, sine of 30 is a half, times 2 is 1, 1 plus 3 is 4. Sine of 45 from your unit circle is root 2 over 2, times 2 is just root 2, plus 3 is 3 plus root 2. Sine of 60 is root 3 over 2, times 2 is root 3, plus 3 is 3 plus root 3. And then that brings us to the top of the circle. Sine of 90 is 1, times 2 is 2, plus 3 gives you 5. Now here's where our values repeat, because sine of 120 is the same as sine of 60. So these values should repeat. Sine of 120 is root 3 over 2 times 2 is root 3 plus 3 is 3 plus root 3. So this is now a pattern, so I'm just going to repeat the values that we got. All right, if you want to double check that, you're more than welcome to pause the video and check for yourself. Now after that, the values are different because in quadrant 3 and in quadrant 4, the sine values are negative. But quadrant 3 and quadrant 4 should match each other. So when we substitute these in, 3 plus 2 sine 210, once we find these, there should again be a pattern present here. Okay, so let's go around. And then you should always, at the very end, get the same value that you started with. It's a nice thing about circular functions and circle graph paper is that it's cyclical and it should come back to where you began. All right, so the first one, sine 210, is negative 1/2 times 2 is a negative 1 plus 3. Gives you a 2. Sine of 225 is negative root 2 over 2 times 2 gives you a negative root, negative root 2 over 2 is a negative root 2, and then 3 is 3 minus root 2. For 240, you get negative root 3 over 2, and so this is a 3 minus root 3. And then for sine of 270, you get negative 1 times 2. So this is 3 minus 2, which is just a 1. And then the pattern's going to repeat. So 3 minus root 3, 3 minus root 2, and then 2. And then at 360, it should match what you had at the beginning at 0. So if you think about that one, you should get 3, back what you got at the beginning. All right, so then you are going to plot these points. So this is the fun part. You're going to see what kind of picture this looks like. So we are going to start with the point 3, 0. And when you graph that, remember you're going to start on the angle line of 0 and go out to the third radius. Then you're going to go to 4, 30 degrees. So out on the 30-degree line, go out to the fourth radius. Now 3 plus root 2, you might not know what that is off the top of your head, but root 2 is like 1.4 or something. So 3 plus 1.4 would be 4.14-ish. So we're going to just kind of guesstimate that. So 1, 2, 3, 4.14-ish. So a little more than 4. And then 3 plus root 3, again, is a little bit further than that. So, again, a little past 4. And then at 90 degrees, we're at 5. And then the pattern repeats. So do about the same thing going back around until at 180, you're at 0. So you're just plotting the same points on the other side. So you should see symmetry there. Okay. Now at 210, and if I'm going too fast, just pause. At 210, you're going out to 2. At 225, we're doing 3 minus 1.1. So that means you're a little shy of 2. And so that means 3 minus root 3, you're a little bit more shy of 2. If y'all want to like actually figure out what that decimal is, you can figure that out in your calculator. At 270, you're at 1. And then at 300, 315, 330, and 360, you're repeating the pattern. So again, you should see some symmetry here and kind of do the same thing on the other side until you get back to the beginning. Okay? Now, what you do here is you connect everything in a smooth curve. It should not look like you're doing like a connect the dots like when you were little and you made everything nice jagged edges. This should be a smooth curve. And it kind of looks like a butt. Now, with these graphs, typically we shade them in. The shading doesn't represent anything. We shade them in because sometimes they cross over each other. And so the shading in just helps you see if they cross over each other, where that happens. This one doesn't cross over itself. So we're just shading it in just because shading is pretty. Okay, so that's your first polar graph. It looks like a butt. It actually has a specific name. We'll talk about that in class. Okay, so let's look at example 2. Okay, example 2 is r equals 3 cosine 2 theta. So with this one, you can see I gave you a different kind of polar graph paper. This one, the graph paper's in radians. It doesn't really matter what kind of polar graph paper you have. This one also has extra lines in here. It's actually marking off like the pi over 12 markings. Where in degrees, that would be 15 degrees. I just wanted you to be aware that there's other kinds of graph paper, which I think I mentioned in one of my earlier videos. There's all kinds of graph paper. There's all kinds of different ways that you can mark the paper. You can use radians, you can use degrees. It doesn't really matter. You should be comfortable doing either one. Okay, but process is the same. We are going to, oh, my pen is not working all of a sudden. We are going to make a table. Now, if you do not feel comfortable substituting in radians, or if you don't feel comfortable substituting in degrees, you are welcome to kind of convert back and forth. That does not really matter. But we're going to stick with what we have here. I'm going to continue to use just these main angles that are here. Even though there's other markings on the paper, we're still going to use these main angles, okay? These are the ones from the unit circle that we should be comfortable with. All right, so we're going to start with 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Now, in the first example, I wrote out everything. You don't have to write out everything if you don't want to. If you kind of understand what's going on, you can do some of this in your head or think through it. But basically, we're going to do 3 times cosine of 2 times the angle. So we're going to do 2 times 0 to get our first value. So 2 times 0 is 0. The cosine of 0 is 1. 1 times 3 gives you 3. All right, pi over 6 is the next one. So we're going to do 3 times cosine of 2 times pi over 6. So you need to think about what that would be. 2 times pi over 6 reduces to pi over 3. So really you're thinking about cosine of pi over 3. Cosine of pi over 3 is a half, and 1/2 times 3 is 3/2, or 1.5. And the next one is 3 times cosine of 2 times pi over 4. That reduces to pi over 2. Cosine of pi over 2 is 0. 0 times 3 is 0. At some point, a pattern should emerge, just like the last one that we did. So I'm kind of waiting for that pattern so I don't have to keep doing math. All right, this one ends up being 2 pi over 3, so we have to think about the cosine of 2 pi over 3. That is -1/2 times 3 is -3/2. I'm guessing my pattern here is going to be that the next one's going to be a -3. Let's check that out, see if I'm right. Might be wrong. We get cosine of 2 times pi over 2. That simplifies to cosine of pi, which is -1 times 3 gives you -3. All right, next we get 3 times the cosine of 2 times 2 pi over 3. That's 4 pi over 3. Cosine of 4 pi over 3 is -1/2 times 3 is -3/2. Do you see the pattern? So I'm guessing the next one's going to be 0, and then 3/2, and then pi. Oops, not pi. At pi, we're going to have 3. That's going to be the pattern. And now let's look at what we're going to have from the bottom half of our unit circle. So 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then 2 pi. And again, there should be a pattern that emerges. And once we see the pattern, we shouldn't have to do as much math. All right. Okay, so 7 pi over 6, let's see. Let's do 3 cosine 2 times 7 pi over 6. That reduces to 7 pi over 3. Cosine of 7 pi over 3. Got to think about that one. Cosine of 7 pi over 3. That would be the same thing as pi over 3. Cosine of that is 1/2. Times 3 is 3/2. So our pattern that we began in the other table is going to continue. I'm going from 3 to 3/2. So this is going to be 0 to -3/2 to -3, back to -3/2, back to 0 to 3/2, back to 3. Okay, the pattern is just going to repeat. Now the more challenging thing in this one is going to be how to handle graphing negative radii. All right, so let's tackle graphing this one. So the first one is 0.30, so go out to 3 on the 0. Now at pi over 6, you're going to go out to 1.5. So that's right here. At pi over 4, you're at 0. So that stays right there at the pole. At pi over 3, we have to graph negative 1.5. So remember, at pi over 3, to graph a negative, you have to come out to this pi over 3 extended. So we're going to go backwards on that 1.5. So that's back here on that extension line. All right, so same thing with pi over 2. For pi over 2, you have to come graph on this extension line. So you're going backwards on that line. And we're going backwards 3. So 1, 2, 3. That's right there. At 2 pi over 3, we are coming backwards on the 2 pi over 3 line. So that's over here. Coming backwards on that 1.5. And then at 3 pi over 4, we're back to 0. Now, on one like this, our shape is starting to kind of cross over each other. So sometimes it can be kind of hard to see what's happening. So our shape is kind of looped like that. So sometimes when that happens, I like to kind of connect it as we go. All right, we left off at 5 pi over 6. At 5 pi over 6, it goes to 1.5. And at pi, we're out at 3. 7 pi over 6 was at 1.5. And then at 5 pi over 4, it's back to 0. So we are looping like this. All right, 4 pi over 3 is another negative radius. So we're doing the extension. So back here, we are going to graph negative 1.5. So it's back here. And then at 3 pi over 2, we have to graph on the extension for that. The extension, we got to go back negative 3. So 1, 2, 3. And then for 5 pi over 3, we got to go back on the extension for that one. That's right here. We got to go back 1.5. So it's right there. So again, we're looping. This looks something like that. And then we're back to 0 for 7.4. And then 11 pi over 6, we're at 1.5. And then at 2 pi, we're back out to 3. And so we come back to where we started. And so what we end up with is a nice little flower. I'm going to make my flower purple. I'm going to shade it in. Isn't it pretty? Aw. I'm going to put a yellow point in the middle. Aw, that's so pretty. And that, my friends, also is a special name that we'll learn about in class. Bet you'll never guess what that one's called. But that, my friends, brings us to the end of today's instruction. I hope you enjoyed it. I hope you have a great afternoon and a pleasant tomorrow.